Good morning. So I know some of you were thinking Brian's going to sing some Journey. That's not going to happen. But I do want to talk about journeys, and us keyboard users, we love the puns. So a little pun for you this morning. So yes, Kubernetes in 2019. Don't stop believing. So let me set this talk. So there's been 31,000 contributors to Kubernetes. Oh my God. That's a lot of contributors. That is a lot of ideas. That is a lot of thought. That's a lot of time. And if you sit in the SIG meetings and you see how the sausage is made, you understand, wow, that's crazy. If you look at Slack, that's crazy. There's been 164,000 commits. This is a large project. I used to actually, I actually had a script that I would go through to summarize the commits for Kubernetes so I could actually pay attention because I was busy at work. I don't do that anymore. Now I just look at the release notes. But here's actually a little stat that I found was pretty interesting. In all the GitHub issues for all the Kubernetes projects, there's 1.2 million comments. You all are a chatty bunch. What are you talking about? It's very interesting to me. So we were talking about our theme this morning, and actually this kind of ties into our theme yesterday. And it's really I'm trying to drive home this thought. And it's not a new thought. Actually, it's funny, I brought this up. Someone quoted it on Twitter, and then someone suggested that Kelsey thought it up. I had independently heard it from Joe Beta, but really what it is, and what I'm hearing and what I'm seeing is that a lot of great minds have thought this. This is actually the truth. Kubernetes is a cloud-native platform for building platforms. Sounds weird. A lot of people don't think about it that way. Kubernetes is not the end. It's not a product. Unless you're a cloud or a vendor, you don't get anything from selling Kubernetes. The real power of Kubernetes is what it allows you to build. And that's how I want us to think about it. Kubernetes is a cloud-native platform for building platforms. We'll go into that just a little bit later, but let's talk about this date. Anyone know what March 6, 2018 was? It's when Kubernetes graduated. It became the first CNCF project that graduated. What that meant is that on that date, a year ago, is when Kubernetes reached a level of stability where we would say, you know what, we've shipped. This thing is stable. You should build on it. You should use it. We are actually on the trajectory for the peak of the hype cycle. This is good software. So what that meant is that we've hit a level of stability. So are we done? But let me, before I do that, this is my mom's slide. You don't get to put your face on a huge slide every day, so my mom couldn't be here, and she's probably not awake yet. But I still want to let her know that her son did it. He's on the big stage. Hi, Mom. All right, so the reason I put this up there is because I actually have a unique job in the Kubernetes ecosystem at VMware. I've looked and chatted and worked with people to do upstream commits, but really what I focus on is taking this whole huge project and figuring out how developers can actually use it, how we can write software that is based on Kubernetes. So I spend a lot of time thinking about what Kubernetes is. A project that you may have heard of that I spent a large amount of time working on is this project called KSonnet, where we were trying to make it easier to do configuration in Kubernetes. This is not a KSonnet talk. I just wanted to talk about it up here. But really what I want to talk about is that we've hit the level of stability in Kubernetes. Kubernetes point releases are still coming, but you don't hear anyone saying, we have deployments and we have services. There is a little rumblings of V2 for some things, But we're not hitting the things. We realize that all the basic constructs we have, they hit 80% of what we're trying to do. It's pretty amazing. But I want to think, I don't want to stop here. We can't stagnate in this realm. We can't just say that we're stable and that's good enough. What we really need to do is understand that Kubernetes is a journey. It is the vehicle that moves us to some destination. And the real neat part is that the destination actually it's a concept. We will never be to where we really want to go. But we definitely want to have a nice vehicle to get us there, and Kubernetes and the cloud native, basically the whole cloud native world is really what's going to put us there. So I wanted to actually, this is a Kubernetes talk, and if you have numbers, for some reason we really like 7. So what I was thinking is there's already been a lot of work in this realm. And I love this chart for the reason that it says that a lot of people have put in a lot of work. I have a project on here. My coworkers have projects on here. Many of you have projects on this screen. We have put in so much work in this ecosystem. But there's things that I think that we're still missing. And I want to talk about those things for the next few minutes. So I am a developer. And I don't consider myself a creative. So what this is me trying to express some ideas here. So Kubernetes in more places. This is not a shoe rack. I got this on Twitter when I posted it last week. It is not a shoe rack. It is a server rack. And really when we originally thought about Kubernetes, when I first heard about it, we were thinking about running it in the cloud, but we really wanted to run it in our own data centers. And that's pretty cool. But because you all can't see my vision, what I decided to do was make a more high fidelity version for this part. So Kubernetes in our data centers, we figured this out. It was difficult because all the server vendors have all sorts of different hardware, and it was difficult getting it up there. So storage and networking, it's crazy. But then we figured out how to run Kubernetes in the cloud. And as all of you probably do, vast majority of you probably do, you are using Kubernetes in the cloud, whether it's a managed service or it's a vendor who's providing it running on a cloud. And then also, if we're going to develop Kubernetes, don't we want to run it on our desktop? And we did work. We had tools like Minikube. We have people who are just running Linux and booting up Kubernetes by themselves. We had Kubernetes on ARM. We have the Micro KS project from Canonical, and we have my favorite thing that I will talk about a little bit later, Kind. But running Kubernetes on our desktop, we figured that out. But let me actually throw something at you. Kubernetes in your data center, Kubernetes on the cloud, Kubernetes on your desktop. Have we thought about Kubernetes in other places? Now, I like nice cars, so I put this car up here. But have you ever thought about, and I'm not saying this is a good idea, so if you put this on Twitter that Bryan says you should put Kubernetes in your car, I will hate tweet you. But really what I'm saying here is, have we thought about it in other places? What would Kubernetes look like in a cloud or in a car? Here's another thought. What would Kubernetes look like in a store? Like let's say you had a huge store and you have lots of computers in stores. And what you want to do is you want to actually use the power provided by Kubernetes to run your point of sales, your back-end inventory management, security, and things like that. Have we thought about that? And even better yet, what about small IoT devices? What about devices on the edge? Are we thinking about how Kubernetes runs on the edge? Should we change it? Do we need to introduce new constructs? I don't know. But really what I'm imploring you all to do is to say, hey, where we are works well. But guess what? The opportunities are endless here. So let's think about how Kubernetes can run in places that it does not now. So like I said before, I think about developer experience more than a lot of people do. And I have something here. And I will say that I love my SIG API machinery friends, so this is not a dig. But here's one of the problems that we have with Kubernetes. Client Go isn't for mortals. Actually, even if you ask the team, you talk about Client Go, and you say that Client Go is hard to use, what they'll say is that really Client Go is made so SIG API machinery inside of Kubernetes works. But that's not good because guess what? We want official clients for Kubernetes. We want to be able to write software that works with Kubernetes APIs. And the issues that we're having is that, you have to understand informers, and you have to understand caches, and you have to understand things like that. But sometimes I just want to put an object in the cluster or listen for changes. So what we want to do, and this is actually a call to action for, whether you're working within the SIGs or you're actually thinking about it yourself. Think about your experiences for your developers. We have to make sure that the barrier to entry doesn't stop people from contributing to the space. And this is another big one. We all know, Kubernetes is written in Go, and that's actually a great thing. The benefits provided by Go, it's a simple language, concurrency is pretty easy, we can teach it to people, is great. But guess what? There is more JavaScript developers out there. There are more Python developers out there. There are more Java developers out there. There are more C# developers out there. And really what we want to do is we provide this first-class experience for Go developers. And there are people out there working on clients for other ones. But as I went through the Rust client, and I went through a JavaScript client, and I go back to the Go client, all the interfaces are different. We should probably think about that. How can we actually make that better? So now, thinking about how Kubernetes is a platform. So, yes, Kubernetes is a platform. We have this idea of custom resource definitions. And really what these allow us to do is actually create new APIs for Kubernetes. It actually allows us to extend Kubernetes functionality without having to change the core itself. So with custom resource definitions, CoreOS created this operator pattern, which allowed us to basically make a custom resource definition, which was just a picture of state, with some code that will actually make the internal state of the cluster look like the actual definition itself or the actual resource itself. But I want to actually ask a question. Is it done? Should we think more? Should we move further? Because here's something I'm thinking about. Operators are a great pattern, but really what it is, if you look at it from someone who's not in the space, operators feel like a crutch. Are we missing something? What is missing? And once again, I don't have an answer or judgment. I'm only saying that we need to think about this a little bit more. So there are people who are thinking about it. Lots of us have written custom APIs or custom resources for Kubernetes. My favorite example, and actually here at this conference, is Upbound and their Crossplane project. What they're doing is they are actually exposing resources that are outside of your cluster, let's say it's a database or anything else, and they're using CRDs to basically say that if you can create objects in your cluster, you can actually have any resource type you like. I love this pattern, and I think we should be thinking about it more when we're actually developing our software. Another example of a CRD that I really like is Cluster API. Joe Beta came up here day before yesterday, and he talked about this. So what Cluster API really allows you to do is say, hey, cluster, I'm going to tell you how to mutate yourself. I want you to be bigger. I want you to use different machine types. I want you to upgrade your version. And now we can actually tell Kubernetes how to upgrade itself. This is an amazing thing. It doesn't matter if you're a cloud provider or an end user. What this does is it gives you a single API that actually allows you to actually change your cluster. This is a big deal. But like I said earlier, operators aren't quite there. What I really want to get out is I want people to think about building on or building with. With operators and CRDs, we're just building on Kubernetes. We're making Kubernetes do things that it couldn't do before, and we're giving it the actual code to make it do that. But think about this, and here's just an idea, and if someone wants to actually sit down and build this idea, I will be your first customer. I want someone to take Postgres, the idea, the APIs, the storage layers, and actually envision what would Postgres look like as a cloud-native application. I have basically a Postgres. I say I want you to install in this cluster. I give Postgres my cluster credentials, and it installs itself, it figures out redundancy, it figures out how to distribute things. And that's way more interesting than operators. Because what it does is it's only one piece of software. And I don't know how we're going to get there. I have some ideas. But think about that. That's pretty crazy. And if we have more software that is this cloud native, API aware, imagine how much power we can get. So earlier, I said kind. I want to shout out to Ben Elder. He is literally my favorite developer in this space. And the reason I like kind, there's two reasons. One is if you create a Kubernetes change before, how do you test it? How do you prove that it works over time? How do you integrate this piece of code? Well, what you could do is you could spin up a cluster. Oh, how are we going to spin up a cluster? Oh, I don't know. We can use Minikube. It doesn't work here, or it might not work here. What kind actually allows, it stands for Kubernetes and Docker. And what it allows you to do is say, if you have Docker running, you can literally spin up a cluster. And not just a cluster, you can spin up any version of a cluster that you want. And even better yet, you can create multiple clusters. And my favorite piece is that you can create a cluster with multiple nodes. This is super powerful. Think about on your desktop, whenever you're running your software on your desktop, and you want to simulate something in production. Being able to run multiple clusters or clusters with multiple nodes allows you to get closer. This thinking, these kinds of projects, not in the core of Kubernetes, but on the peripherals of Kubernetes, are the projects that are going to take us to the next level. Kind is actually, I think, is literally my favorite thing. So actually, I want to give a shout out to Ben. I know he's here. I saw him the other day. Shout him out. This is really one of the coolest pieces of software we have out right now. So another thing that I like talking about is declarative configuration management in Kubernetes. I like talking about it because whenever I say it, I sound really smart. Declarative configuration management in Kubernetes. But here's another thing. So one thing that I've seen out here, and I want to preface this again, this is not a talk of snark. This is a talk of love, and I really just want to push us forward. I see you all as my children, and I want to see you run your bikes and not fall. But where we're in configuration management, we're still not hitting the bar. There is great projects out there like Helm. But here's the problem with Helm. The problem is that Helm is basically our cloud native analog to Debian packages or RPMs. Great in their own realm, but think about this. No one is writing a whole bunch of tooling or trying to basically rig RPMs to install and own their own life cycle with other tools. What we did is we built tools like CF Engine and Ansible and Chef and Terraform. That's what we need to think about. So we do have stuff out there, Customize is now in there, but we can think further. There's lots more analogs that we can have in this space. So on the state, I know Sada Lee talked about this. I just wanted to put this on the big stage. This is bad advice. Don't run stateful workloads in Kubernetes. The new advice is it depends. And the difference is I'm saying no, I'm changing the no to maybe. It is still complex. There's a lot of moving pieces. But we need to understand that Kubernetes, because it is stable, has made these things possible. And even though they're not easy, we need to think as a group and as a community how to make this stuff easy, because it definitely can happen. So another piece here, and this is actually the most important thing of all, is community. We have to build our community. We have to maintain our community of corporations, of the foundation itself, of our end users, of our maintainers. We have to empower. We have to do that. So one thing we need to do is we always empower the end user. That's how we default. The second thing we do is we turn those end users into contributors, and then we turn those contributors into maintainers. And that's how we do this. So I want to leave with just a little summary. Don't stop believing. I am so happy to be able to do a talk like this because we have come so far, and it's crazy. I can't even see where we would go next because there's so much surface out there. So here's my summary. If someone wanted to take a picture of that and say, what did Bryan talk about for 20 minutes? That's what I talked about. So last slide. And I am not going to sing, but I really want to say that song, go listen to Don't Stop Believin'. Just think about that. We really can't stop. and we won't stop. And now I'm quoting Diddy. That's awful. But this is where we are, and my time is up. So thank you all, and I'm so happy to see you. Thanks for the invite, and thanks for coming.